Okay, last week we were talking about functions. We're talking about x as an input. We're talking about multiplication, division, etc. Absolute value as our operators. And then we're talking about y as our output. And that's what you have here. You have your in and your out. And here's your operators. So that's what we're working with. Now, in order for you to determine whether or not the function is working properly, well, whatever your input is should match up with whatever your output is. Now, you have 5 different values you could use. I always like to pick the value, in this case, 1 and 12, which is easiest to work with. 1 is the easiest to multiply with, so that's what I'm going to use. Now, I have to run these inputs through most of these functions in order to find the one that's working properly. In this one, 4 plus 1 plus 8 gives me 12. That's a match because my input of 1 gave me an output of 12. Now, I have to be careful because what could work in one case may not work for another input, so I want to test that. 4 times 3 plus 8, 12 plus 8, that's 20. So that's good. I mean, that does help me identify that this here, in fact, is my correct function. Now, as an example to show you guys kind of the idea of functions that aren't working properly, well, if I put 4 times 1 here plus a 23, I would get 4 plus 23, 27. And you see that my input did not give me an output of 12, it gave me an output of 27. So I know that this is not something that's functioning properly. So let's say that this y equals 4x plus 8 was at the bottom. Maybe it was the last option. I would run 1 through each of these functions until I got to one that worked properly. And when I do get to one that works properly, I would try and work with another input to make sure. All of these you could see, if I plug in 4 times 1 minus 33, that's going to give me negative 27 or negative 26. And then same thing here, 4 times 1 minus 8, 4 minus 8, that would have been negative 4. So that's not the output I was looking for here with 12. And that's just basically how you determine inputs, outputs, and operators. Now they will give you a question that kind of involves the table which we worked with, the equation we worked with, and making sure that the graph is appropriate here. For me, this 0 and 5 is easiest to work with for a couple cases. One, it helps me determine that actually these are the only 2 graphs that are going to work for me because they're the only 2 graphs that have 0 as my x-coordinate and 5, so this coordinate of 0 and 5. You could just match up coordinates and find this graph. I think best way to work with this here is then to say, okay, 9 times 0 plus 5 is 5. If I put in my input and my output, I'm actually substituting both variables in this case. I get 5 equals 5. I get a function that actually is equivalent on both sides. But here's the problem, and this is why I brought this up. Let's say I do 9 times negative 1, right? So this worked. I plugged in the 0 and the 5 and this worked. Oh, that's my answer. Well, be careful. Let me try another input just to make sure it's working. And you should be doing that in real life. Okay, if this is working in this case, let me try something a little different and make sure it's continuing to work. Negative 9 plus 5 is actually negative 4. Negative 4 is not equal. Oh, actually, we're good here, right? Are we good here? 9 times the negative 1. Oh, I'm sorry. It shouldn't have been plus 5. I made a mistake here. It should have been 9 times negative 1 plus a negative 4 is equal to 5. Here I have -9 plus a -4. If I'm adding two negatives, I'm getting a total amount of negatives, so -13. So we see here that although this worked with the 0 and the 5, we see that when I plugged in a -1, it actually doesn't work anymore. This doesn't work. So we know this to be, this is actually not going to be the function. And if I do the same thing here, -9, and I'll plug in the 0 plus the 5. The 0 can be a dangerous input because 0 times any number is 0, so you may get a lot of true statements like this here, so that worked. But when I try the 9 times the -1, like I did here, plus the -4, I get a +9, negative times negative +9, plus the -4, and I get a 5. And then I do, in fact, get the 5 equal to 5, which is what I wanted. So this would have been my correct answer. Now you can also use some of these coordinates. Now you're limited because there isn't a 23 or a -13 on this graph, so you're not really sure. So inputting your values is something you might have to do here. Although remember when we started with the 0 and 5, because if you see on this graph, the 0 and 5 is not plotted. So the 0 and 5 point is not on these lines. So that's how I would have eliminated these questions here. Or these answer choices, let's say. This is a good one here. You're using X values. So one thing you want to start off doing is just simply making your little table here. We can make it in a column table. The other ones were done in rows. And then what's going to happen is I'm going to plug in my X values. So 1/2 plus 5 gives me 5 1/2. And then I'm going to plug 2 over 2. We'll put that over here. 2 over 2 plus 5. So I'm plugging in this second value. 2 over 2 is 1. 1 plus 5 is 6. 1 plus 5 is 6. Now, what do you notice about the trend here? This is going up. And if I do 3 over 2, or 1 1/2 plus 5, that's going to give me 6 1/2. So if I start to see this trend, it's basically just going up by 1/2. So what do I notice? I notice that this, as my X values are going up, my Y values are going up. So right away I know I have a relationship that's going to yield or give me a positive slope. And the only two answer choices with a positive slope are D and B. So I can eliminate the A and C. I know right away that's not going to be the answer because these are negative slopes. They're going down. These slopes are going down. Now I have to match up 1 and 5/2. That's right there. If I plot my X coordinate here, 1 and 5/2, 1 and 5, it would land here. If I plot that here, there's no point. So since this point is not on the line, I know that's not my answer there. And I just made a table by plugging in my X values, solving, getting my Y values, and finding which graph matches up. In this case, answer choice B. And if you see 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, there's my 4 and 7 point too, which also works.
So my number on my practice is X over 3 plus 2. I see.
I will. So if I get an X over 3 plus 2, that's just saying if I'm plugging in my values, now that's just going to be 2 over 3 plus 2. So it'd be 2 2/3, like this. That's all. You're just working with a different fraction. So if it would be 3 over 3 plus 2, that's going to be 1 plus 2. That would be 3, yeah. So it's basically going up by 1/3.
Once I get to 4, I forgot to do it. Do I, what's it called? When you, it's an improper fraction, right? It's 4 over.
Yeah, so any improper fraction, so if you got 4 1/3, your 4, it's 4 over 3 plus 2, then it becomes 1 1/3 plus 2, and then you would make it 3 1/3 like this.
Oh.
Understand?
Yeah.
And then This last one, it's the same thing. You're making a table and graphing, kind of same one we just worked with. -2 minus 1, 0 minus 1, 2 minus 1, 3 minus 1. And you're just getting your values. -3. Be careful just going up. But oh, it's just 1 because it goes from 2 to 0. So it actually skips a number there. 2 minus 1, 1. 3 minus 1, 2. And then I'm going to go, so I have -3, -1, 1, and 2. And I'm going to take these values and try to find the -2, -3, 0, -1, 2, 1, 3, 2. And there's my match. And I could just even graph that on the side if I wanted to. And just kind of say, okay, -2. I'll just use 3 slashes here in each. -2, -3, 0, -1, 2, 1, 3, 2, just so I can find a graph that would match. And this 0, -1 is an important point. I love the 0 points because that's your y-intercept. Here's a 0, -1, it's not there. It is here, so that could be an answer. Here's a 0, -1, that's not here. So I could do quite a bit by eliminating answer choices. All right, practice and hard work, that's how you guys are gonna get through all this. So